So we had these two functions, our two functions f of x, actually we have three, f of x, g of x, and h of x. However, we are combining the two functions together to try and form this composite function or composition function. And that function for number 17, the one we'll take a look at here, is h of f of x. So we need the f function. That's where we're going to start on the inside. And then we'll try and work with the h function, trying to apply that f function to it. So starting on the inside, f of x is 2x plus 3. So now we want to try and form the composition function of that. Jaden, what would you do to try and form the composition function? We have h of 2x plus 3.
You would take 2x plus 3 in parentheses plus 5 divided by 2.
Nice, yeah. So she said we're going to take this part here, place it in parentheses. So we have an x plus 5 divided by 2. And that x is the 2x plus 3. Nice job, Jaden. If you keep it in parentheses, like where the x is, you can literally see how it's replacing x in the equation. And then we do a little bit of simplifying because everything in the numerator here is all divided by 2 because x was divided by 2. All of it's being divided by 2. So we can combine a few like terms, actually one like term. We have 2x, and then if I add 2 and 5 together, we get 8. So if you look at this, can you do any other simplifying? So can we simplify this any further? Is there any way to reduce this fraction? Brooke, what do you think? Can we simplify this any further?
Yeah, we can divide all of it by 2.
Excellent. Yeah, and she said all of it. So 2, 8 on the top and the bottom, they all can be divided by 2. So if we divide everything by 2, we end up with x plus 4. So I'm going to just rewrite my answer over here. H of f of x would be equal to x plus 4. Any questions on 17? So looking down at the word problem, this is talking about coupons, and I will tell you, I love coupons. I especially love Kohl's because at Kohl's, I get like $5 off coupons, and then I get 20 or 30% off coupons, and you get to use both. So I love coupons, and I like shopping at Kohl's or anywhere that I can use 2 types of coupons. So not just one, that's not good enough for me. I want to be able to use 2 coupons when I go. So in this case, you have a coupon for $200 off a computer. When you arrive at the store, you find that the computers are on sale. So it's not a coupon, but at least they're on sale, which is even a good thing too. The computer, the sale is 20% off. It says let X represent the original price of the computer. So the first question says use function notation to describe your cost with you only using the coupon. So only using the coupon, we want to figure out the cost of the item. And it says X is the original price. So writing it in function notation, my original price is X. If I only use the coupon was $200 off the original price. So it would be X and then minus 200. Because my original cost, whatever it costs for the computer, $400, $500, $800, minus the $200 off. The second part says use function notation to describe your cost with only a 20% discount. Now this one you have to think a little bit about. How much would the computer cost if I had a 20% discount? Or how could I calculate that cost if I had a 20% discount? Valerio, how could we write a function for number 26?
G of x equals 4/5 x
Yeah, and how did you get 4/5?
because you subtract 20% or 1/5.
Yeah, so the discount is 20%. So that means my 100% cost minus the discount gives me an 80% cost. That's what I'm paying of the actual product. So if you have a 20% discount, it's taking 20% off the original cost. So he said multiply it by 4/5. You could also say, I'm just going to multiply it by 0.8. Either one of those is acceptable. But a percentage cannot be written as a percentage in a function because it's not a numerical value, it's a percentage. So 80% is the amount that you would be paying for the item. We write that as 0.8, or as Valerio said, you could write it as 4/5. Any questions on creating those two functions, 25, 26? All right, so then looking at 27, it says form the composition of functions, F and G, that represent your cost if you use the coupon first, then take the 20% discount. So when you're forming a function, and it's a composite function or a composition function, whatever function is inside is what you do first. So when I look at this, it wants us to take the coupon first. So that needs to be inside the function. And my coupon was f of x. So that goes on the inside. The discount was g of x. That's going to go on the outside. So whatever you're finding first needs to go in the middle, because that's really what you do first. You start on the inside and then you work your way to the outside function. So our inside function is x minus 200. That's the coupon part. I'm using the coupon first. Then I need to apply that to the discount. If I apply that to the discount, my discount was 0.8 because I'm paying 80% of the item, and then times x. Well, x is x minus 200. And again, use parentheses. That x, replace it. Use parentheses when you're replacing that value. So then I would have 0.8x. And then Valeria, what is 4/5 of 200, or 0.8 times 200?
160.
Yeah. So I would find the original, or I would find my discounted price, whatever I'm paying for this computer. I want to first subtract the $200, and then I'm applying that to the 20% discount. And then 28 is the opposite. So 28, I would do the coupon, or I'm sorry, the discount first, and then the coupon. So the discount is g of x, that goes in the middle. And the coupon was the f of x function. Are there questions on that? So my g of x is the 0.8. And then if I apply that to x, I would have 0.8x and then minus 200. So there I'm multiplying my cost by the discount first, the 20% discount, 20% off, and then I'm subtracting $200. Are there questions? The last one says, would you pay less if you used the coupon first or took the 20% discount? So kind of comparing 27 and 28 and looking at those two. So here was my answer for 27. Here's my answer for 28. Annabelle, which one would allow you to pay less for the product?
The one if you use the discount first.
Yeah. Because if you use a discount first and then take off the $200, you're using the discount and then subtracting $200. Whereas the other one, you end up after you multiply and simplify, you are actually just taking off $160. So that would be taking the discount first and then subtracting the 200. I know for a fact Kohl's takes the money off first. So they'll take the coupon, like $5 off first, and then they take the discount because it's not as much off, but it's still using two types of coupons. Does anyone have questions? Any questions I didn't answer? All right, so we are going to start section 6.4 today. Please make sure you submit your virtual attendance for the day. Anytime we're virtual, you need to submit your attendance. Yes, I'm taking attendance, but it's more for myself when you're at home. So please make sure you submit that attendance for yourself today. As right now, tomorrow, we don't really know what's going on tomorrow. It's supposed to be a hybrid day. Please have your parents or yourself check your email at some point today or regularly today so that you kind of see what is going on tomorrow. Because right now, they have not said if it will continue to be a hybrid day or if Group A will be back in the building. So please check your email today so that you can kind of look for those updates. All right, so we're going to travel over to section 6.4, looking at inverse functions. As I said, the couple of sections that we're working with, we're trying to see what types of operations and how we can take two functions and try and analyze them and maybe combine them together with operations or combine them together with substitution. And today we're going to look at trying to verify inverse functions and find inverse functions. So this is kind of relating one equation to another equation. What would the relationship be, this inverse relationship be? And we're going to start first by defining an inverse function, or I'm sorry, an inverse relation, and then we'll talk about the inverse function. So an inverse relation interchanges the input values with the output values of the relation. So let's talk about what that means. Interchanges the input values with the output values. So we're talking about this word inverse, and it's saying we're interchanging the input with the output values. So I'm going to make a little T-chart because a relation can be written in T-chart form. And I'm just going to make my T-chart go horizontally. We talked about a relation in chapter 2. A relation is just a mapping or pairing of X and Y values. So we're going to just have a couple of X and Y values here and see if we can try and find the inverse of them. So I'm just picking random numbers here. We'll pick 4 numbers. So a relation pairs an X and a Y together or an input and an output together. So this is my original relation. To find the inverse relation, it says interchange the input and the output values of the function. So I'm going to make myself another T-chart down below. Grace, what do you think it means to interchange the input and output values of the function or of the relation? What would the word interchange mean? Ella, what do you think interchange means? If you're interchanging the input and the output values, what do you think that means?
To switch the x and the y values.
Yeah, so what would that look like if we switched X and Y?
The x values would be 2, 6, 10, and -2. And the y values would be 3, 4, 5, and 6.
Nice, yeah, that's it. So interchanging is another way of saying switching. You're switching the X and the Y values. So that's how you find an inverse relation, by taking the original and switching the X and Y. Well, an inverse function happens when both the relation and the inverse are functions. Remember, for it to be a function, each X has to have one Y value. So if both of them are functions, then we have inverse functions. So both the relation and the inverse are functions. Then they are considered inverse functions. We write an inverse. So that's my original function, f of x. The inverse function is written with the little notation of a -1 as a superscript with the f, the function. So this little -1 here is raised, kind of like raised to the -1 power, but that represents the inverse function. So we would say the inverse of f. And we use the same function because it's related to the f function. So if f is a function, my inverse function I use with f -1. So that is inverse notation. So we're going to see if we can find a couple of inverse functions. And it is really simple finding an inverse function. So it says replace f of x with y. So it's going to say it's a function because it must be a function in order for us to find an inverse function. Switch x and y, solve the equation for y, and then finally replace y with the inverse notation. So it says we want to find an inverse relation. The first one is an equation. The second one is actually function notation. So we're going to follow these steps, and it's really easy. So replace f of x with y. Well, letter A already says y equals, so I don't have to do that. The next part says switch x and y. So literally, we're going to go into the equation, and we are going to switch x and y. So this is now going to say x equals 3y minus 5. An inverse is found by switching the input and the output, or the domain and the range, or the x and the y. Literally, you're switching those variables because they're opposite variables. So to find the inverse, I'm taking the opposite variables and switching them. And then it says to solve. So Ava R., how would you solve this little equation for y?
You would have to get y by itself.
Yeah, what would you do first to get y by itself?
Add 5
Yep.
to both.
All right, so add 5. And then what would you do, Ava?
Divide all of it by 3.
Yeah. So now we have y by itself. We solved for y. The last step is to make sure you're using the inverse notation. The inverse notation is using f -1. Actually, let me go back here because it's y. Y -1. It doesn't say f, so I want to make sure I'm relating it to the original function or the original equation. And then x plus 5 divided by 3. And that's it. So Friday's homework that you had, whereas working with solving for y, just to review getting y by itself so we could find the inverse. So this function is the inverse of the original, or that expression is the inverse of the original. So we're going to try the same thing with part B. This one is function notation. So f of x equals 1/4 x plus 2. So I first make this y equals, and I'm just going to cheat. I'm not going to write it again. Just make it y equals. And then you switch x and y. Faith, what would you do to solve this equation? Sorry, I missed my y here. For y.
You would add 2 or subtract 2 to
Yep.
both sides.
So let's take the
And
2
then,
over. And then what? How do you get rid of 1/4 times y?
multiplied by 4.
Awesome. And I love that you said multiply because we don't want to divide by 1/4. So to get rid of the 1/4, you multiply by its reciprocal. So we're going to multiply by 4. Now here's the little tricky part. On the other side, when you multiply by 4, that is a quantity. All of that has to be multiplied by 4. So the 4's cancel. We have y by itself. On the other side, we have 4x minus 8. Don't forget to rewrite it in inverse notation. So my inverse is 4x minus 8. But again, that quantity, once you have a quantity on the left side, all of that quantity needs to be multiplied by 4. You have to keep it equivalent. So what you do to one term, you have to do to everything. That's the same thing with that fraction. So if we have a fraction, we have to do the same thing with the top and the bottom. If we have an equation, you have to do the same thing to every term of the equation. Does anyone have questions with finding inverses? Pretty straightforward. Okay, so the next thing that we're going to talk about, there were 2 things today. So we did the one part, we found the inverses. Now the second part is to verify inverse functions. So functions are inverses of each other if they meet 2 conditions. So functions f and g are inverses of each other provided f of g of x equals x and g of f of x equals x. So there's a difference between finding an inverse, which is what we did in example 1, and showing 2 given functions are inverses of each other. So finding an inverse is the process of switching x and y and getting an inverse function. Showing 2 functions are inverses of each other is a process using composite functions. We discuss composite functions right before we do inverse functions because inverse functions are based off of composite functions. And both conditions have to be met. So this is one of those conditional if and only if statements. So f of g of x must equal x and g of f of x must equal x. And it says that f negative 1, that inverse, can be read f inverse or the inverse of f, depending on how you want to state that information. So we are going to verify that the functions are inverses of each other. And we have 2 functions here. So we have the f function, 3x minus 5. And then we have the inverse, 1/3 x plus 5/3. So we are not finding the inverse here. We're not going to switch x and y. We're going to verify that these 2 functions are in fact inverses of each other. To verify, we need to take the composite of these 2 functions. So we're going to take the function f with the inverse of f. That's supposed to equal x. And then we're going to take the inverse f with the function that is also supposed to equal x. That's how you verify that functions are inverses of each other. So using composition functions, we're going to start on the inside. So we're starting right here on the inside. We'll work on the left side first. So I have my function f, and I'm replacing it with the inverse in the middle here. So the inverse function is 1/3 x plus 5/3. So we're trying to show that the function in the inverse should equal x, the composite of those. So the f function says 3 times x minus 5. If I replace x with the inverse, 1/3 x plus 5/3. Now I have a composite function. Gabby Soul, what would you do to try and simplify this now? So we replace the inverse in the function f. How would you simplify it?
Would you distribute the 3 into the parentheses?
Yeah, what is 3 times a third, Gabby?
3, or no, 1.
Yep. And then 3 times 5/3 is?
That would be 15 over 3.
Yeah, what is 15 over 3?
5.
Excellent, nice job. And then minus 5. What happens, Gabby?
You would get just x.
Yeah, we just get x, which is our goal. So you see how they're opposites of each other and they cancel each other out. That's what inverses do. So they're opposites, so they're kind of canceling each other out. They're inverse operations. So now we have half of it done. Nice job, Gabby. Let's work on the other half. So this time, we're going to use the original function, 3x minus 5. And we're going to plug that into the inverse function. So the inverse function was 1/3 times x plus 5/3. Well, x is 3x minus 5. So if we simplify this, Julia, what happens when we distribute 1/3 into the parentheses? What is 1/3 times 3x, Julia?
3x over 3.
And what is 3x over 3?
1.
Yeah. And then if we look at the next one, we have 1/3 times negative 5. So how would we write that, Julia?
Negative 5 over 3.
And then again, Julia, what happens here?
They cancel out again to just get x.
Exactly. They cancel out to just get x. Nice job. So the last little check here. This is our goal, to show that the two functions are inverses. We need both of them, the composites, to combine and simplify to the value of x. So verifying functions are inverses is taking the composite of the function and the inverse and simplifying it down to just be the value of x. Does anyone have questions? So we are going to do one more problem. And there are 3 in example 3, and I don't think it's necessary that we do all 3. So we're going to look at one of them. Why don't we do the one in the middle? Let's look at letter B. So it gives us a function, f of x equals 2x minus 1. This is a 2-part question. It says find the inverse of the given function. So that's part 1. Part 2 says verify that your result and the original functions are inverses. So we first have to find the inverse, which is what we did in example 1. And then we're going to verify that they're inverses, which is what we have in example 2. See if you can first find the inverse function. Again, we're going to look at B here, of 2x minus 1. So switch x and y, and then get x by itself. So add the 1 and divide both by 2. Make sure you write inverse notation. And I'm just going to keep it as x plus 1 all over 2. If you want to write it as separate, you can do that as well. You could write x over 2 plus 1 over 2. Totally up to you. I think sometimes it's just easier leaving it as a combined fraction. All right, Brooke, we found the inverse. how do we go about verifying that our result and the original function are inverses of each other?
You have to make sure both of them equal X. I don't know how to explain it.
Yeah,
It's
no,
like-
that's perfect. That's fine. Both of them equal X. I know exactly what you mean. So we're going to take the inverse which is the answer that we just found. So we're taking the original function and then the inverse function that we found. And we need to make sure that when we take the composite of those two functions, that it reduces down to X. So my original function was 2 times X minus 1. And I'm going to plug in X plus 1 over 2 in place of X. All right, so let's look at this problem here. We have 2 outside, and then X plus 1 divided by 2, and then a minus 1. How could you simplify this?
Could you multiply by 2 to get it out of a fraction?
Yes, we are going to multiply it by 2 to get it out of the fraction. If I have 2 over, whoops, it was supposed to change. 2, it still isn't changing. 2 over 1, there we go. And then inside, I'm dividing by 2. If you're multiplying by 2 and dividing by 2, those operations cancel each other out. So I can cancel the denominator that was dividing by 2 with the number outside because I'm multiplying by 2. Because multiplying and dividing are opposite operations. So they would cancel each other out. And then we're just left with X plus 1 because that's the only part remaining inside, and then minus 1. Which we know that the plus 1 and the minus 1 cancel, and then we're left with X. So just like look to see what you have. If you're multiplying by 2 and dividing by 2, they cancel each other out. All right, now we need to do the opposite. So now we have to have the function in the inside. And our original function was 2x minus 1. So the inverse we have is x plus 1 over 2. We're replacing the x with the function 2x minus 1. Which means that I have 2x minus 1 plus 1. My 1's cancel. The 2's cancel, and we just have x. So notice we had opposite operations in each of those. We had a positive 1 and a negative 1. We are multiplying by 2 and dividing by 2. Those are inverse operations, and that's why they cancel out and reduce just to the value of x. Does anybody have questions? So your homework for today is a worksheet. And that worksheet is on inverse functions, but it's also on composition of functions. And I want to show it to you here. There it goes. So it is posted to Google Classroom. The first 2 questions give you 2 functions, and you're supposed to determine if they're inverses of each other. And then it does say justify your answer with supporting work. So these are like the problem we just finished. You don't have to find the inverse, but you need to show that f of g of x equals x. So determine if they're inverses of each other. You need to do both cases, f of g of x equals x and g of f of x equals x. So that's the two problems here. So you're not finding the inverses because both of them are inverses of each other. The second group of problems wants you to actually find the inverse. This is where you're switching x with y, solving for y, and writing it in inverse notation. So again, these problems, you're finding the inverse. And then on the back of the page, I gave you a pair of functions. And in those pair of functions, you're performing the composite operation, the f of g of x, and you're stating the domain. So I believe there's 4 of those questions, and then the last 2 problems are evaluating for a given value of x. Are there questions? There should be an answer key posted as well. Oh, there's not. Unless it's on the bottom here. Oh, the answers are right here. There we go. So the answers are attached to the actual assignment itself. So does anybody have questions? All right, so have a fantastic day. Please, again, make sure you submit your attendance and check your email periodically throughout the day so that you know what is going on for tomorrow. And Julia, I just saw your question, so if you don't mind staying on, I'll look at the question that you asked. I apologize for not seeing it earlier.
Okay,
Have a
thank
great day.
Miss
Thank you.
Jane, I have a question about the homework real quick.
Sure.
Sorry, Julia.
No, that's fine. Well, I mean, she might not be fine with it, Brooke, but I'm okay with it.
So for this one, do you want us to write like f of g of x and then write g of f of x?
Exactly.
And then just solve it like that?
Yes, exactly.
Okay. I just wanted to make sure.
Yep. Nope. That's good. Good question.
Okay.